Making appropriate assumption. Making appropriate assumption, we should recognize that the mathematical formulation of a physical problem represents an ideal description or model which approximate but never quite match the actual physical but never quite matches the actual physical situation. When we construct an ideal mathematical model for a given engineering problem, an idealized mathematical model for a given engineering problems, certain approximation will always be involved. Some of these approximations may be mathematical, whereas others will be physical. May be mathematical or whereas others will be physical. For instance, it is often necessary to neglect a small distance. Neglecting small distance, angle, or forces. Compare it with large distances. Angle or forces. Suppose a force is distributed over a small area of the body on which it acts. Distributed forces. We may consider another as approximation. We may neglect the weight of the steel cable if the tension in the cable is many times greater than its total weight. For in the cable problems, neglecting the weight of the cable, however, if we must calculate the deflection of a sag of the suspended cable under the action of its weight, maybe in the some problem, thus what we may assume depends on what information is desired and on the accuracy required. Thus, what we may assume depends on what information is desired and on the accuracy required. We must be constantly alert to the various assumptions called for in the information of real problems. The ability to understand and make use of the appropriate assumption in the formulation and solution of engineering problems is certainly one of the most important characteristics of a successful engineer. One of the major aims of this book is to provide many opportunities to develop this ability through the formulation and analysis of many practical problems involving the principle of statics. Using graphics are an important